Right. So good evening and for Asia, and also good afternoon. Yeah, I guess over there is afternoon for people in Europe. So welcome back to RoboCup at Home Education Challenge 2020. So today is the last class for our final class for our standard platform, Pepper 2.9 Android version. And today, similarly, so we have Luca here, and also me, and also our fellow colleague from SoftBank Robotics. So thanks to everyone turning up. And as the final class, so we will do some adjustment. So we will start with the content about the competition. Then only we will proceed to the technical content, right? So I will start with very important, yes. This slide is very important to promote our activity. So after this, we will proceed to let all the teams prepare for their development. Just as a motivation, so we have discussed and confirmed this with SoftBank Robotics as our sponsor. So we will provide award and certificate. So this award and certificate is divided as what you can see. So first is like we will award all teams, registered team who submitted a reasonable project, which is some extension and integration of the parts provided. So you've got the example throughout all the classes. So from there, you will do some development based on the theme of the competition, and you try to compile them together, assemble all the parts together to come up with some creative and meaningful application. And then you submit, you register. First, you need to register. So as a reminder for all the team, please remember to register your team first. Okay, after this, please register. I will post up the link soon. Okay, after I finish my introduction, then I'll post up the link. But you can find the link from the website. So for all the teams that register, and you're supposed to submit all your stuff for the video challenge. So there are, I will tell you more about the detail later on. And we will review on your work. So based on the review and everything, so if you have submitted reasonable project, which is we can see like you effort in your, so the teams will be awarded with a participation certificate. So this is an agreement that our committee member have made. And also we are very happy that this time SoftBank Robotics actually sponsors the awards and certificates for this Pepper 2.9 category. So we will have these goodies, as you can see, like this Pepper figurine. So I think this is a much nicer trophy. In fact, I myself won this. Right.
Definitely.
Yeah. So for the teams, we will based on the number, because now we still estimating and adjusting the number that joining for this Pepper 2.9 category. So as a reminder, so Pepper 2.9 and 2.5 will be graded separately. So we will have different rank. So particularly for this 2.9, we are very happy that SoftBank Robotics Paris, Europe, actually agreed to give out this figurine and also goodie bags and also award certificate. And it will be like in gold award, silver award and bronze award. And but the number of the award that's giving out is based on the number of participants. So we need to see how many teams we can gather, and based on that, we will give out the award based on the usual at-home RoboCup at home percentage. So based on that, we will try to adjust that. Yeah, right, Luca.
Yeah, I don't know if Clarice want to add something at this point.
Yeah, so maybe like Clarice, you can say this because it's an award by your team.
Hello, everybody. Nothing special to add. As every year, I mean, this is the first year we sponsor the At-Home Education Challenge. So, like for the other leagues, we are always happy to give some awards and continuing supporting the events. So. I would say good luck, everybody. And I think this is important also to say this is great to be able to offer those presents to the for the Pepper. I mean, for the Pepper 2.9, but we won't forget those who are participating with Pepper 2.5, of course.
Yeah, of course, that one we have
Yeah.
quite similar arrangement, I guess, but we will do the announcement in the particular class.
Yeah.
Okay, so not a
So
problem.
good luck,
Yeah,
and do
so
not
everyone,
hesitate to do not hesitate to ask for any question.
yes, okay, right. So if you have any question, you can ask using the chat group chat. You can just type in there, and we have plenty of co-hosts here, so we will try to answer your question. And for the meantime, please allow me to explain more a little bit about this competition time schedule. So I presented this in the first class, but as a reminder, or those new participants that's just joined our class. So as a reminder, so I will tell you the procedure or the flow that what is going to happen after this. So we have done our online class, 6 classes, yeah, almost 1 month and plus. So it's very fast. So we have come to the final class today. Then after this week, from May 21st to June 1st will be the team development period. So during this time, you are supposed to do your development for the competition, right? And we understand that there are many teams, especially when we check the entry form. So many teams actually reflected that they don't have they don't have access, or they don't have the robots, especially for this Pepper 2.9 challenge. So we have this special robot development support, okay? But this robot development support is not that we are going to help you for your development, but more on help you to execute your development on physical robot and do the video recording. Okay, so that is the difference. So we are not going to help you if you can't do your development. Okay, so you have to do your development, but we SoftBank Robotics will help to execute your program in physical robots and do the video. But that comes with some condition. The condition is we need to make sure that your work is complete. That's the first thing, able to be executed, and also it have certain value, which means you have come up with some reasonable development from the example given, right? And how this is judged is based on the review process by us, the community member, and also by SoftBank Robotics. Okay, so in order to do this review, you are supposed to submit the review material. So this particular for the teams who don't have access or don't have your own robots. So if you have your robots and you don't need any help from us to do the recording of the video, and you are fine to do everything by your own, you can actually skip this part, no problem. You can straight away prepare your video and submit by June 10th, right? The 10th of the June for technical video challenge. Okay, you can directly send your work. Okay, but that is another submission. So over here, I would like to clarify this different, because like there are quite some confusion why there is a submission in 1st of June and also another submission in 10th of June, right? So let me clarify this. For the teams that require support to help you execute your program and do the video recording, please submit the review materials. And please mind you that the review materials over here and the submission for technical video challenge are different things. Okay, so please, they might be related. Okay, the content might have some overlap, but they are 2 different set of materials. So please be clear on this procedure. Right. So later on, I have a slide to tell you more about what is this review material for robot development support. So let's go with the time schedule first. So once you submit on 1st of June, we will do the review quickly to see if your work is worth for the SoftBank Robotics to help you to do the execution and recording. And we will do this recording in 1st of June until 10th of June, right? During these 10 days, we will try. And during this period, we might have some communication between us. It depends on how the things work, how it will happen during our video shooting. So for extra clarification or extra, okay, so please keep in mind that during this period, please make it with us and also SoftBank, okay, right? So the final thing is like we will come up with video for you, right? Then with this video and also some other videos that you make at home, part of video that showing some simulation, or you have some presentation that you take into to explore this video together and compile become a very submit for the technical video challenge. And that submission is the final things that you are going to submit to us before the final. The member will quickly review all the technical video challenge and select. The final will happen during the RoboCup week. It's 2 days from there. So I think like Luca still need to do this, inform you. So on after 15th of June, we will contact you and you have to print. So that is the online challenge. And during the online challenge with us online, okay, and I think like we will use this Zoom, but presentation and demonstration online, real time, to judge all the submission. So you're going to buy, and we will do the judging. Later on, I will tell you where to find the rules and so on. But you can find all this information from 2 days. We will have 1 day that do the setup, so you can set up smooth, and you can do some testing and so on. And then for the final, will be informed later because we still have to plan out how many teams and who and how. First, now everyone please focus on the technical video challenge and submit the video. Okay. And for those teams that don't have,
I'm just saying that for the finance, so it will be in this video.
Okay. So yeah. So we will coming arrangement. So please, the first thing you need to do is register any email from us. Okay, because we don't have your contact. So there's so that we will contact you for the activities. Without the robot, you have support, right? So now about the technical video challenge. Yeah, no problem. Okay, right. So you need to submit a video description paper, which is and also operation in the video. Okay, you can read more detail. It's like maximum A4 size 4 pages. Okay, so we don't really. You're supposed to host your video online somewhere. You can do it. Don't send your whole 100 meg of video using that format. Okay, so to make sure that we don't miss your email. Okay. Of the challenge, which is what are the contents that you need to have the part of presentation and so demonstration. So it's very in any way you can stand in front of the camera with your project, but more importantly is the demonstration of. Okay, so if you're a robot, then you can use the video from SoftBank. If you don't have robots, and for the presenting. And what important thing is like you need to make interesting and attractive. We didn't set really the time, 15 minutes, or out of that is about 8 to 7 minutes, but it won't help you to score. Okay, so because I don't think all the things. So try to make it very short presentation, and the presentation mostly is talking about the technical application, is to demonstrate to show that your robot's able to. Then we have 3 teams over here. Join this competition. You maybe don't know what exactly the task set. These 3 teams, and you can select either one. So the first 2020, go to the website and you can find this rule 2020. There are 3 tasks that you can choose. One is find my mates, and the third one there. But what I can say is like it actually gives you you're supposed to develop your robot to complete the task, right? For example, like carry my one to carry the luggage from the living room until outside. Materials that you learn in this paper 2.9 classes. Of the tasks that you can do. So these tasks may be not so suitable for here. Although solving the competition task is the first team, but we have 3 tasks. Many questions, many people asking me if they are summary and clarified to you. You can select either one of the, or you can do all. So it's totally up to you, right? Okay. So if actually, for example, like the last task, the receptionist conversation involved. So you can use the receptionist task. Okay, but that is what also create your own task, and that will fall into rules 2020. So if you look at the same rule books, that is open scenario. So you can design your only not sure how complex or how complicated or how much content you need to really give you roughly the idea how complex or how you need to deal with, what kind of people inside there, how they, for example, you want to ask people like to get something about, the open scenario, you can design your own. And lastly, if let's say you have actually many ideas and also application for service robot in the current example that you might want to design a pepper robots to, I'm not sure about delivery, the medicine and so on, but there will be, these are the things that, yes, it's possible for Pepper to do. Suggestion from our Pepper engineer.
Yeah, just a suggestion to the which you design what the robot should do and then try to implement it to map. So you start from what you come to some ideas, because of course not design a task which is too difficult of top down. That is the design of what the robot should do. You take what you learn and you put them together. So that's one thing that you want to show.
Yes. Do we have any examples of SoftBank? You want to say anything? All right. Okay, never mind. I'll proceed. So, what you can do and what you're supposed to do for the video, a little bit more information about this robot development support. And this will figure out like most of the teams that sign up for, I think this is very important. I think almost every team's required. You need to submit your review materials by 1st of June. And which is us and also SoftBank Robotics to help you to do first all the project file. Okay, and also the execution file. More detail, but yeah, you need to submit us. And the way, like what Luca have mentioned and also show you, submit us with the link so that we know like who for your work. Then, similar, you need to also provide us a project files or any form. Okay, you can put in diagram, you can even record an explanation about the content that you submit to us. You need to tell us how to execute your program and like give a hello or do something, so that your robot will, we can expect what to happen and to make sure that this happen during our process and give you the video, right? Anything on this?
No, it's fine to me. See what is submitted exactly, but
okay, right. So if everything is okay, so know how to execute your program nice or not, to shoot a video or not, right? So this is very important. If we are not going to help you, right? So you need to run the program. Okay, then submit all this information to us, the OC email. Okay, so maybe like, yeah, you want to say something, on this?
Well, just repositories on GitHub, and this is a link video. So it's a possibility that can be used by teams. You can do it with any other tool. So Git is just a protocol. There are many clients in order to manage a Git repository. So we can process a tool. You can use whatever you want. What is important is that it's also possible. I've seen that most of you, my team, that was the first GitHub that we have given in, can also continue to work on that repository and that repository. So anyway, if you have any question or any.
So I hope by now you should have some idea what to do in your, because I saw in the question that you still don't know. Application is to produce a Pepper application, whether you can follow the competition task, which is your own, or you can do something that with, and so you need to see what you learn and how you can position yourself to come up with some you learn in the class in real world application. So that is the, I'm supposed to do this thing last, but never mind. So today the okay, and
form that has been communicated before. So this is just for teams who did not yet.
Okay. Yes, right. And then and 10th of June, right? That is the first thing that you need to know. Right.
Send other instructions by email to all the registered teams. So to register, because so you will receive communications from us. If you are already registered, you know you have aids from us, and we will code about these deadlines.
I can pass to you.
Yes, thank you.
Anything from SoftBank? Question?
No, I just ask. I'm Louis. Hello. Or if it's okay, you can give us feedback. We are all right, or we need some help.
So remind you that next Monday we will get, all the teams have received an email about it. So we are available on a session course, how to use GitHub.
Yes, and during the session here, you can also ask us for the explanation you give, but do not hesitate in asking.
Sure. SoftBank engineers is very, very helpful and very useful. Also, organization part, let's switch to the technical part. This last part is about how to combine multiple actors that we can create actions and make robotics isolated. So we have seen examples in which at every step there was only one action running at every time. How to compose all this action, how to we have seen example of running actions, for example, in which you can create an object, lies the action like this, and then run the action, and you will have the robot say an action that is linked to an animation, and when you run animation. So today we will learn running the actions. So we assume that we understand how to create the action, especially when we want to run these actions in a composed way. So an action, like say one action, gorilla action, and you have two modalities to run the action. Using the run method to the action, in which you use this other format that is to run. So what's the difference? It's very important to understand. So the synchronous action is also called a blocking action function that is executing the action. The piece of code that you are which this instruction appears will not proceed. So the function is called say blocking because it blocks till the action is finished. While when we use the asynchronous modality, the function is non-blocking. That means that while the action is running, code in which this instruction appears can continue. And so they understand the timing, the schedule, the temporal. There is also another aspect that I will comment later on, is that we have two threads running. One is user interface, and another thread is working with the robot. Synchronous actions cannot be executed on the action synchronously on a user interface thread, interaction with the user interface, and it will not work. This, and I will show you as an example later on, functions in the UI thread. So this happens during the execution of an application in your Pepper robot. You are in this UI thread, so the thread that is managing the user interface, which is the tablet in this case. And at the beginning, then what happens is that in a portion of the process that is execute the on-robot focus gain method. So you remember I will show you methods in our class, Java class that we define. Start of an application in which we have the UI thread, the system thread, a robot thread with write the instruction, the command say to be a say action in the robot thread. Then this will locking form. So it means, for example, in this case, the Pepper robot will say hello, and the action is finished. So for example, we have a text that speaks many, many words will be executed only after all the words have been spoken by the robot. While the robot is doing the action, this piece of code is in. If you run the action in an asynchronous way, now we have different way of run is created. So now the action is not running on this thread, but what happens is that since this call now is that while the robot is executing the process can continue. Okay, so you have another action after the say, you will have that this other action, for example, the say action, okay? Because again, the async start the execution of the action, but will continue the execution of this run action. The two action, animate and say, that will do at the same time, speaking and moving like so. This is important, and there are situations in parallel and other situations in which you want if I want the robot to first finish the spoken part, then I have to use a different mechanism. So as we made in the on-robot focus gain method, we are inside a synchronous and asynchronous mode of running the action thread. So when we write a piece of code not inside us, I will show in a while, then in this case, you cannot action synchronously, okay? So the action dot this piece of code inside the on-robot focus gained function. We will see that in general, we are not in this situation. So we usually want to depend on some user input, for example, on the robot's tablet. And when we press a button, we want to start, need to run the actions in the UI thread, but we cannot use the synchronous mode. We always have to use the asynchronous mode. So, for example, this is the example which we have the user interface, the tablet with the button, we start an action. But this is very important, okay? So this means that when we push the start button, the action started asynchronously, but actions. For example, we can execute another asynchronous. If you want to run these several actions in parallel, sure, because you already have a way of running asynchronously several actions. For example, that we have seen in a previous lecture, if you want to start a say action after you press a button, you are exactly in this schema. So you press the button, and this means that the two actions will run in parallel. To do something more complex, for example, if you want to make a sequence, you want to start animate only after, for example, we want to interrupt an action. Imagine that this action takes a lot of that takes a lot of time. I want to interrupt. To make a more complex combination of actions, we need an additional structure. This structure are called. It is impossible to define correct elements because it would involve probably I don't know, concurrent programming and so on. But let's say that references to tasks that are running in the future. Okay, so this means that when you start an action, you produce results in the future later on. Okay, the action asynchronously. Okay, so at the moment then we have the reference of execution of this action from now until the action finishes. Okay, and something that is happening now and it's going to continue for the future in order to, for example, the action. So a future is a reference to here at this moment when this particular we don't know yet what's the final outcome of the action. So what we can do with this reference is to, first of all, to monitor. So we may know, for example, if the action is completed in the future after the action is finished at some point. So that's, of course, understanding how to use these futures to do reasonably complex uses of the futures. One is this method and then a task. I can decide what to do in the future is finished. So in this way, and then compose, I can say that in the future, I can do something that will be written here, of composing one action with another. And this of the action, and it will link the next one. This will happen in the future. So this instructions is executed. So this action monitored by X written here, okay? And while this a function that asynchronously say that at some point the task be canceled. So this allows, for example, to have behaviors in which it should stop doing whatever it's doing at that moment. Okay, so what for, of course, the futures can be used to create a very complex task futures. We will see only this and then component read in the documentation. And so we will see in this lecture composition or a sequence of this. What is interesting is that and then compose, it's with another future that can be composed with another future and so on. Dot and then compose, dot and then compose, dot and then compose, way of defining a sequence of actions. When you put in a sequence all these calls to do something, and then when this something is finished to do something else, and then when all the previous parts are patterned by using this way of composing sequences of actions. And we are guaranteed that the next action is correctly terminated. And another of the behavior of the robot, we can request for cancellation. So something that composes different futures for canceling all the sequence. So now consider as a single task, a task which is composed by the sequence of creating or defining tasks as a combination of different tasks. This means, for example, that if I'm doing the front of this future, this will cancel also the example that you find in the kinds of actions. Say actions, animation actions, we introduce another kind of action, which is the definition of that is an action, okay? Also, the chat is an action. The chat is an action. We don't show example because we want you to integrate this. It will be very useful for your project. Please extend this by adding also a chat action. So the chat action can be used in the future. It can be interrupted. It can be put in a sequence. We will focus on these three actions. And so you know already about the session. Also another tool that you find in the Android. This is a very convenient tool to design trajectory. This tool is available here. So if you go to the Android Studio, you have in the menu some, you see some tools that are specific of the Pepper SDK, for example, the chat topic, and the animation, the trajectory tool. Run this, you can create a trajectory, and you can create the trajectory by moving this. This is the top view of your Pepper robot, and you can different positions of the and different orientation, and you can, for example, preview. So this will be, for example, the path of the task. So you can draw, execute this trajectory. So this is a top view of the robot. Nice, of course, is that you can physical robot, and this time you will actually see the Pepper robot moving in this environment. So far we have seen actions in which the robot was not moving from its the arms. But now with the trajectory editor, you can see the actual robot moving in this space. And I will show you this in a while. So trajectory is like this, and then we can create trajectory actions. So let's go to the code of this definition of a set of actions. And we have actually a total number of actions that is 2 say actions. Say one act, welcome to the show. Then we have the robot says, I hope you enjoyed. Then I have an animation action that loads one of the animations that have been robot that we have seen already. And then we have this just an action linked to the design. Now, I already designed this trajectory, here's any other trajectory. So when you define a trajectory with the trajectory editor, the trajectories are resources available here, this trajectory to an action in order to here in this function, we just define the actions, but we do not execute the action. So you see that there is no run method. So in this way, we are creating the references to the actions, but we are not running the actions. This function init actions is called within the on robot focus gain. So here we could run also the actions, but we want to make the actions running not at the beginning, but only when, for example, a user interacts. Focus is gained, that means when the application starts, we just create the actions, but we do not execute the actions, okay? Then we added here 2 buttons in the user interface that are a start button and a stop button, a behavior when the user pushes the start button and to stop the behavior. So this means that we want to execute the action only when the user, we have to define a reference to the part again in a previous lecture. So we define a button, we take the object, add the listener for this button, and we do the same for the stop button. The start button is while the stop button is associated to this other execution. User interface thread is run when the user pushes. Means that here in the user interface we cannot write, okay, this behavior will be wrong into the user interface thread, because this will block the UI thread and it will not be interesting. So, but then if we run asynchronously, and this will be correct, we cannot, for example, action starts after the other, okay? So now what we want, button, we want to execute the actions in a sequence and not in parallel. So we cannot use the asynchronous mode, and we have to implement a composition. So this portion of the code says that a listener that execute the code defined here. So what is execute actions? We define the behavior that the robot has button is pushed. And here we decide the parallel, in a sequence, one after the other. So it means that only when the previous one is completed. So the robot says, hello, welcome to the show. Then the animation, then a trajectory action in which the robot moves around, we play in the trajectory. Then again, another instance of the gorilla action. Then the robot says the final, and that's it in terms of the action. We added a log instruction just printed here only when all the full behavior is. The actions are run in an asynchronous mode, but the future composition. And this means that asynchronously, but it's monitored by the future that will make sure that the next action will be executed only after the first one is finished. That is, will make sure that the third action will be executed only when the second one is finished. We will complete this behavior by this message here on the screen. This behavior, so we can play this application. We will see that, okay, so we append this before we interact with the tablet. Created the actions here, but we didn't execute any action. So the robot is not moving, okay? Because we didn't set that will actually start the execution of the action is linked to the listener of the start button. So this is executed only when a button, you will see the sequence of the action. So the robot will first say the first sentence, and so on. So let's push the start button and the gorilla action. Now the robot is playing the trajectory environment, following the trajectory that has been designed with the trajectory editor. Then we have another gorilla action, and only at the end we see here in the screen. Okay, to use the future and you write all one after the other, they will be tried, they will be executed. It will not work. For example, if you try to write the code which you write after say to action async.run, of course this will not work because you can say in parallel. And the same for the animations and the trajectory. Schedule multiple actions, put these actions in a sequence one after the other. Stop button. So the stop button is linked to the exec future. All this process is asynchronous, and this is important that this function is executed immediately and by thread. So it means that while the robot is doing all its few seconds, you can interact. That's why it's important to use non-blocking function. This particular case is that will stop the behavior. So let's start. The robot starts again. You see the execution. And now you see that the robot stops while, for example, in this case, the robot trajectory action and does not proceed. So it didn't do for each. Okay. So this means that when we start the behavior, gorilla action, the full behavior is stopped. So this means that, by the way, also you see that it doesn't play, it doesn't write execution says not be completed until the end. So this a complex behavior that is the sequence of file, and we have this object who is monitoring the future of this behavior. And we can use this object at any time, for example, to request cancellation. In this case, this cancel the all task that is in this case when we have a sequence of actions when you will be cancelled. As I mentioned before, it is possible using a different combination of futures, but we'll not cover this. But even with this simple way of to generate more complex tasks. The chat action is also an active user and the robot, and it's also interesting to understand actions, physical actions of the robot with the interaction. I don't know if people from SoftBank want to add something. Otherwise, I think that we can complete. So here, so if anyone wants to add something, do not hesitate to interrupt me. So here you function on asynchronous programming, which is the topic, but there are something that can be done easily. So anyway, here you have more infogramming, and again here there are references to the code that we have. So let me summarize everything. So we came to the end of this short and intensive set. We have produced all this material for you, and this is just a summary. And let me conclude this telling that what we gave you is a set of ingredients showing how to do something, and now your task is to put this ingredient recipe. Okay, so we have seen in each lecture one particular aspect of what you can do on functionalities that you can test without a physical robot, but just with a simulator and emulator. And now you have many ingredients that you can ask. And this is exactly what I would like to propose for this challenge. So as we commented, and to try to design top down what is the task of your that you want to implement on your robot, take into account also what you learned during these sessions and the ingredients that we have seen in these lectures in order to, and then you can always incrementally make it more and more complex. I don't know, Jeffrey, want to add something at this point? Or?
Maybe I could just, sorry, just want to say that if anybody has any questions, there's a lot of resources on the internet, but also feel free to specific points, and we can often point you to resources on that, either code, documentation, etc. If anything is unclear.
Definitely. Also, because maybe you have an idea, you cannot evaluate how difficult it is. So do not hesitate also to possible, because maybe you will not be able to evaluate if something is possible. Spend a lot of time to try to find some your ideas are also very important suggestions about what is actually possible.
All right, Ian. So just as a reminder, so I sent, this one is the tender list. Okay. Please fill in your names so that we know who went today. So this will be the last one. Then also I've created one feedback additional announcement. So we will start new classes. Okay, invited lectures. I'd like to know your opinion or your suggestion or that you attended, whether you attended like all the classes or just one class. We like timing is okay and the topic is okay. The materials that you take about 5 minutes to fill in the form, or you can fill in later on. You just so that we can keep in touch with you because you're going to put down your email so that it's after this series. Okay, so this is something beside, right?
Thank you very much, everybody. Steve, now it's your part. We did our part of teaching. Now it's your part to show us and what you can put together will win the wonderful awards that will be given for this challenge. Let me thank again SoftBank for the support in producing. To say that I'm the speaker, but most of the technical content has been provided by SoftBank development of these classes. And also we thank them also to support the teams and of course also for the awards.
Thank you.
Okay.
Well, yeah, but would like to thank Luca to actually more capacity to actually handle this class as well, because I'm handling everyone to join. Although today is the last class, the final class for this paper 2.9, but our event's still ongoing. In fact, now is so I would like to encourage a lot of you to still stay in touch with us. Worry if you cannot finish like 100% or it's not really like you feel that you're confident with your work, please send up to us and we'll try to help you as much as we can. Right. Stay together until we will like, which is the end of next month. Right. So please don't go away and
yes. This is valid also to people who are not live, but they are watching the recorded video. So even if you get to this lecture do not hesitate to contact us for participation.
Yes. Everyone for until this point, like join all our activity after this.
Very well. Thank you, Jeffrey. And of course, thank you to all the participants. And
yes, okay. So we will see you next Monday. And
yes.
I hope after this class you have to start like code. Right. Then we will in Java. So
bye-bye, everybody.
Thanks a lot.
Thank you very much.
Thanks a lot. See you next Monday. Bye-bye.